Hello friends, so today we will read how to prove the irrational numbers. So if you are in class 10 and if you are appearing for 2024 and 25 board exams, this is very much helpful. And you know this term 1 examination is coming in the next month, September. So let us start. Without wasting time, we will start with root 3. So prove that, the question will be like this: prove that root 3 is an irrational number. Root 3 is an irrational number. So this root 3 is an irrational number, yes, we know, but we will prove this by method of contradiction, or we can say logical reasoning. So let us see method of contradiction. What is contradiction? Contradiction means just the reverse we will take. What is given? Root 3 is an irrational number. So to prove its irrational number, let's take it's a rational number. So let's take first. This is the first step. Proof. Let root 3 is a rational number. This is the first step. Okay, if we are taking root 3 is a rational number, there is a common property for all rational numbers. So what is a rational number? We know that rational number, I am doing a rough work here. Rational numbers are expressed in terms of rational numbers. I will write normally the rational number set is expressed in terms of Q, and it is P by Q. It is in the form P by Q. All the rational numbers are in the form P by Q. What is P and what is Q? P belongs to Z. That means P is an integer. P belongs to, this is read as belongs to. P belongs to Z, and Q also belongs to Z. Q also belongs to Z, means Q is also an integer. It may be positive number, it may be negative number, but Q should not be 0. Q is not equal to, this is the condition. If any way you are writing the rational numbers, you can take any number, any integer, it may be positive, it may be negative, or it may be 0 in the numerator, and you can take this Q or the denominator any number, but 0 you will not take. Why we will not take 0? Because if you take 0, then the division process will be meaningless or undefined, we can say. And some students, they tell it infinite, but let us tell it undefined, or division process is not possible. So this is the condition. So this condition is for rational numbers. It's a common formula for rational numbers. So now rational number means we have taken root 3 is a rational number. That means root 3, if any rational number can be expressed in terms of P by Q, then root 3 is also can be expressed in terms of P by Q. So let's do that. This implies that root 3 is equal to P by Q. What is P and what is Q? So this condition I will write here. P belongs to Z, means P, or you can write P is an integer also you can write, or you can write P and Q are integers also you can write. But this statement, if you express like this, then it will be short actually. So Q belongs to Z and Q is not equal to 0. This is the first condition. Now, after taking these conditions, another very important condition we have to write, and that is, how important is it? If you don't write that step, which I am going to write now or explain now, all the method will be wrong actually at the end, and you will lose marks also. You will lose marks. So let us prove that. Let us tell that P by Q, here that condition is, suppose the number is 3 by 5. These two numbers are known as co-prime numbers because their HCF is 1. 4 by suppose 4 by 7, like this. So these two numbers, P in the numerator and Q in the denominator, so that HCF or their common factor is only 1. 1 is the common factor, nothing, no other number is the common factor of them actually. So that we can write here HCF of P and Q is equal to 1. HCF of P and Q is equal to 1, and some students, they may write in a different language here. This is shortcut one actually. You can write P belongs to Z, Q belongs to Z, and Q is not equal to 0. That you will write definitely. With that, P and Q are co-prime. You can write that also. Or you can write there is only one common factor of P and Q, that is 1. Or 1 is only the common factor of P and Q. You can write that also. So why to write a long sentence? You can write either this one or P and Q are co-prime. Simple. So this is very important. If you don't write this step, you will definitely lose 1 mark. And if you write these 2 steps, 1 mark is sure, 100%. 1 mark you will get. So now let us go for the next step. Implies that. Now what I will do, root 3 whole square P by Q whole square. What I did here, I did squaring both the sides, means LHS is squared and RHS is also squared. So I will write here squaring both the sides. So by squaring both the sides, what did I get here? Let us see. Root 3 square means root 3 into root 3, that is 3. Root 2 square is root 2 into root 2, that is 2, like this. So this is 3 is equal to P square divided by Q square. So P square divided by Q square, what I'll do here, now I will just take Q square here. This is 3Q square is equal to P square in this way, or we can write this alternate way, implies that P square is equal to 3Q square. We have reached at an important point here, very important point. So let us discuss this point here. P square is equal to 3Q square. What does it mean? P square is equal to 3Q square. Value. P square, some value I have got, which is 3 into something. 3 into something. So what does it mean? The value of P square is 3 into something. That means if you multiply that something, means that number in 3 or with 3, then you are getting P square. So can I say 3 is a factor of P square? P square is what? This is P square, right? This number is P square, means 3Q square. So this is P square. So 3 is multiplied. So 3 is a factor of P square. So can I write that 3 is a factor of P square? So 3 is a factor of P square. Now from here I will draw a conclusion. Let us draw the conclusion together. So 15 square is equal to 225, isn't it? So 15 square, that is P square. Now, so this is 225 is equal to, it is 2 plus 2 is 4 plus 5 is 9. So 9 is divisible by 3. So 225 will be divisible by 3, isn't it, dear friends? So can I say now this, if P square is divisible by 3, or 3 is a factor of P square, I wrote here. So can I say 3 is a factor of 15 also? Another example I will take, 6 square is equal to 36. So this is P square. P square means 6 square is 36. 36 is divisible by 3. That means 3 is a factor of 36. 3 is a factor of 36. So 3 is a factor of 6 also. Similarly, 3 is a factor of P square, means 3 is a factor of P also. This implies that 3 is a factor of P. This is equation 1. This is very important. Equation 1, right? Now, if you got something, 3 is a factor of P in equation 1, let us go for Q. What is Q then? And we will check whether 3 is a factor of Q or not. Now, if 3 is a factor of P, that means 3 is a factor of P square, means how you are writing 3 into something. So 3 is a factor of P means you will write P is equal to 3 into something. Let that something be M. So I will take here, let P is equal to 3M. What is M here? Because we know that 3 is a factor of P. So I can write M belongs to Z. m belongs to z. So means m is any integer. If you multiply any integer with 3, you will get the value of p, isn't it? Now next step, similar steps we will get. This implies that p square is equal to 3m whole square. What did I do? Same step, squaring both the sides. Squaring both sides. Squaring both the sides. What answer I will get? P square is equal to 9m square. Now dear friends, you see p square means what you have got here? 3q square. So can I write, instead of p square, I will substitute the value 3q square. Why? Because about p I got the information in equation 1. About q I need to get the information. So instead of p I will substitute q so that the value of q I will know. This implies that p square means 3q square. 3q square is equal to 9m square. 9m square implies that, again I will come to, I don't need 3q square, I need q square. So q square is equal to, this 3 is multiplied with q. So I will bring q this side, bring 3 this side. So 3 will be divided, this is multiplied, this will be divided. 9 by 3 means 3m square. Now this kind of equation I got here. Q square value, what did I get? 3 into something. If 3 into something is there, that means that value is multiplied into 3. Some value, some 3 is multiplied there. So it's a multiple of 3. If it's a multiple of 3, can I say 3 is a factor of q square? If 3 is a factor of q square, then similarly 3 is a factor of q. 3 is a factor of q. Now this is equation 2. You have got 2 equations, which is now a tremendous part. You see, 3 is a factor of p, 3 is a factor of q. What does it mean? Can we say 3 is the factor of both p and q? Both p and q means what? 3 is a common factor of p and q. Now what did you take here? In the beginning you told our assumption was HCF of PQ is 1. That means there is no other common factor than 1. Means there is only common factor 1. P and Q have only common factor 1. But here what we got? P and Q have another common factor 3. What? This is a contradiction. This does not suit, this does not match our assumption that we have taken here. We have taken HCF of P and Q is 1. If HCF is 1, how come this 3 becomes another factor then? So this is wrong actually. So we can write now from equation 1 and 2 we are getting here, from equation 1 and 2 we get what do we get? 3 is a common factor of P and Q. 3 is a common factor of P and Q. But this is wrong, because what do you write here then? In the next step, we will write 3 is a common factor of P and Q. The next step will be, we will refer to this. We will write this is not possible, because our assumption is P and Q have only common factor 1. So we can write here our assumption is wrong. Our assumption is wrong. What we have assumed, what we have taken root 3 is a rational number. So that is wrong. If something we have taken is wrong, then which is correct? The opposite is correct, isn't it? So we can write the assumption is wrong means root 3 is a rational number, that is wrong. So what can I write? Root 3 is not a rational number. Root 3 is not this. Here I am writing here in the box. The final step I will write here. Our root 3 is a common factor. See, from equation 1 and 2 what did you get? 3 is a common factor of P and Q. But why this is wrong? Our assumption is wrong because you have taken the common factor is only 1. So our assumption is wrong. If our assumption is wrong, what you have assumed? What you have assumed? Root 3 is a let. Where you have written let, that is the assumption. Let root 3 is a rational number. So that is wrong. So root 3 is not rational. So not rational, one word substitution is what? Not rational means irrational, isn't it? So root 3 is an irrational number. Proved. The small square mark is given for prove mark, right? Or you can write proved. It is proved now. If you have proved, you understood now. Again I repeat the steps in terms of words. Let whatever number is given, take that, let's it be rational number. If rational number, then p by q. If p by q, then p belongs to z, q belongs to z, and q is not equal to 0. That means integer, and denominator is not equal to 0. HCF of p by q, p and q is 1. Then squaring both the sides. These steps are common steps for all the numbers. I will put here. Now 3 is equal to root 3 square is 3, p square by q square. Then 3q square is there. If p square is equal to 3q square, then 3 is a factor of p square, then 3 is a factor of p. If 3 is a factor of p, then let's take p is equal to 3 into something, that is 3 into m. What is m? M belongs to z. These all steps you have to write. So then p square means squaring both the sides again. Same steps here. What did I do here? Same steps will be repeated here. P square is equal to 3m square, p square is equal to 9m square, 3q square. Where did I get this value? P square means here 3q square. 3q square is equal to 9m square. So q square value I need. So 3 is coming here and divided with 9. So 3m square. Q square is equal to 3m square. So 3 is a factor of q square. 3 is a factor of q. So from equation 1 and 2, what did we get? 3 is a factor of p and 3 is a factor of q. So 3 is a common factor of p and q. But this is not true. This is wrong. Our assumption is wrong. Why? Reason in mind. Because HCF of p and q is 1. You can write in the bracket also. Because HCF of p by q is 1. We have assumed that HCF of p and q is 1. So this is wrong. If our assumption is wrong, what our main assumption we have taken? Root 3 is rational. So root 3 is not rational. Written root 3 is not rational. Not rational means what? Irrational. So root 3 is an irrational number. Proved. So if you have proved this with root 3, then how can you prove with other numbers? Similarly, suppose here root 3 is there, root 2 is there. Here also root 2 is there. You see, same format. Here root 2. Only change numbers. Remaining format will be same. Root 2 square is, this is 2 and this is 2. And this is 2. You see how easy is this? If you got a format, then it will be easy. 2, this is 2. 2 square is 4. Don't forget to do that. Then this is p square is equal to, what do you get? This is p square, 2q square. Only numbers change. This is 4 and this is 4 by 2 is 2. Remaining writing is, instead of 3 you go on writing 2. You will be correct. See how fast I am writing. And this is 2 and this is 2. Proved. Right? Similarly, in case of root 5 also, similarly we will do that. See 5, suppose 5. I am writing, I am just changing. 5. Prove that root 5 is an irrational number. Yes. Root 5 is a rational number. Root 5, p by q. This writing will be fixed actually. This is a format. Root 5 square. This is 5. This is 5. Only change the number. 5. This is 5 is a factor of p square. 5 is a factor of p. And if p is equal to 5m, m is same writing. Only numbers will be changed. Instead of root 3, put 2, 5, 7 like this. So this is 5. This is 25. Just a change here. 5 square is 25. Just please mind this. Otherwise it will be very, odd actually. So this is p square is equal to here 5q square. Put 5q square. This is 25m square. Now this is 25 by 5 is 5m square. So 5 is a factor. This is 5 is a factor. This is 5 is a common factor. 5 is a common factor. Right? So now our assumption is wrong. So this is 5. This is 5. 5 is root 5 is an irrational number. So this is a strong format that you got. In this method you can prove root 5, root 2, root 3, any number. This is a common format and this will come as 3-mark questions, and this kind of question are coming very regularly actually. So now what I'll do here, I will tell you two different methods, two different questions actually, which are common. This is one. Now, as I told you in the beginning, mixed numbers. Mixed numbers. Mixed number means this is single irrational number. Now, if I will take mixed irrational numbers, how I will do that? Let us see. The format will be same. Suppose next question, next type of question I can say, that is one type of question, this is another type of question. Next question, prove that root 2 plus 1 is irrational. This will prove that. Now how I will prove that? Now, and the data will be given here, root 2 is irrational. This is the data, it is given. Root 2 is irrational, then prove that root 2 plus 1 is irrational. How to do that? Now you see, proof. Root 2 plus 1, the given number. So let that root, again method of contradiction means take the reverse assumption. Let what you have to prove? Prove that irrational, then take that rational. So root 2 plus 1, let root 2 plus 1 is a rational number. Rational number. If that is a rational number, then again you will start with your own. Root 2 plus 1 is equal to p by q. Instead of p by q, you can write a by b, m by n, whatever digits you can take. You can take x by y also. Normally we take p by q or m by n or a by b for our convenience. P by q. Again that condition don't forget to write. P belongs to z means p is an integer. Q belongs to z, q is an integer, and q is not equal to 0, denominator is not equal to 0, so that the division process will not be completed actually, and the HCF of p and q is equal to 1. This you will write. This is very important step to get marks. Implies that here you don't need to do squaring both the sides. Why? Because already this is irrational, it is given. So irrational part you keep it in LHS. This is rational part, right? 1 is a rational number, confirm. So you take 1 to that side is equal to p by q minus 1. P by q minus 1. Now you can solve this or you may not solve this. Listen, this is q is the denominator. Q will be the LCM. So Q cancel and P will be there. Q by Q is 1. 1 into P is P minus Q1 ja Q. Normal division. So now you see P, Q and this is integer. This is integer and this is integer. Just think, integer minus integer. You will definitely get either positive integer or negative integer, isn't it? It depends on the bigger number or smaller number concept. So this will be the integer 100%, and this is already integer. So integer by integer is what? Definitely, and q is not equal to 0, already you have taken. Q is not equal to 0, you have already this. That means this number is definitely a rational number. And what is this number? Irrational number. So now you have got a different kind of equation here. Root 2 is equal to p minus q by q. Now you see this one, root 2 is confirmed that it is irrational number, and the p minus q by q is confirmed that this is rational number. Is this possible? Irrational number is equal to rational number. This is not possible, right? So we are coming into a different kind of contradiction actually. So this is not possible. So root 2, we will write here, just mention root 2 is irrational given, or we know, and p minus q by q is rational. So what will write here? This is the contradiction, right? But this is not possible. This is not possible because rational number cannot be equal to irrational. If this is not possible, so our assumption might be wrong. We have taken a wrong assumption. What you have assumed, like the before question, root 2 plus 1 is rational number. This is not possible. So our assumption is wrong. Our assumption is wrong. What is your assumption? Root 2 plus 1 is rational number. So root 2 plus 1 is not rational. Not rational. Not rational means what? Irrational. So this implies that root 2 plus 1 is irrational number. Finish. Proof finish. Like this, any kind of number here will be given, you can prove this. It may be root 2 minus 1. It may be root 2 minus 1. It may be root 3 minus 1 or plus 1, or it is 5, maybe any number. You just keep, what is the main basic step here? Keep the irrational part at the left, take the rational part to the right, do the solving. Definitely the right part will be rational and left part will be irrational. That is not possible. If that is not possible, next will be our assumption is wrong. If our assumption is wrong, then that given number is not rational, because you have taken rational, not rational. And finally you write root 2 plus 1 or any number that is given is irrational. This is a format actually. This is same. This step and this step are same actually. This is not possible. Our assumption is wrong. The given number is not rational. The given number is rational. Given number is rational, right? This is one type of number. Another type of number, these are root number and simple rational numbers. If both are root numbers, then what we will do? Both are root numbers. The last 4 steps will be same for everything. Actually, the root 2 proof, root 5 proof, root 3 proof, there also we did like that, isn't it? So now we will take a mixed number. Mixed number means like this. Next type of question, root 2 plus root 3. The question may be root 2 minus root 3, root 2 plus root 5, root 3 minus root 5, root 5 minus root 3, root 2 plus root 7, root 2 minus root 7, any number you can have. So this is an irrational number. We have to prove. This we have to prove. Again, method of contradiction. Take the ulta. What is the ulta? Let root 2 plus root 3 is rational. Proof, huh? So let root 2 plus root 3 is rational, right? Again, dear students, if rational, then root 2 plus root 3 is equal to p by q. Again, that step you don't forget. P is an integer, p belongs to z. Q is an integer, q belongs to z. And q is not equal to 0. You have to write this, you can't miss this. And HCF of bracket you can give, HCF of p and q is equal to 1. This you must write. Then we will go for next step. Here both are irrational. In the previous question, previous type of question, one is irrational, one was rational. So you, what did you took? You took the rational number to the RHS, solved that. RHS you got rational and LHS you got irrational. So what do you do here? This is rational part we know and this is irrational part we know in mind. Now what we'll do, to get rational number we have to find the square of this one. Again, squaring both the sides like the previous question. Squaring both the side. Root 2 plus root 3 whole square is equal to p by q whole square. So what did I do? Squaring both the sides. Squaring both sides. Or you can write simply SBS. In some books also it is written SBS, no problem. So root 2 plus root 3 whole square, it just behaves like a plus b whole square. This is a plus b whole square type. If it is a plus b whole square, then what is the formula? A square plus b square plus 2ab. So now put that a square, which number is in place of a? Root 2. So root 2 square plus root 3 square, a square plus b square, then 2ab, 2 into root 2 into root 3. So a square plus b square plus 2ab. Can you see this? Okay. Now is equal to, this is continuing, p square by q square. This implies that root 2 square is, you know, root 2 into root 2 is 2, root 3 into root 3 is 3 plus 2 root 2 into root 3, root 6. 2 3 is 6, root over of 6 is equal. This cannot be done further simplification. So now this is p square by q square. Now you see this is finally 2 plus 3 you can add. This is 5 plus 2 root 6 p square by q square. Now you see 5 plus 2 root 6, 5 is rational and 2 root 6 is irrational, is equal to p square by q square. We cannot add this. Some students, they make the error, they add 5 plus 2 7. Don't do that, because irrational number, this one sorry irrational number cannot be added to the rational number. Now we will go ahead with our same process. Now 5 plus 2 root 6, you keep the irrational part at the left as you did in the previous question. 2 root 6 is equal to p square by q square minus 5. You can keep it like this also. because this part will be definitely irrational, I mean rational part, right? So now what you are getting, this is 2 root 6 is irrational, and this is p square by q square minus 5 is rational. Is this possible? This is irrational and this is rational. Can an irrational number be equal to rational number? Not at all, isn't it? So again, our same step will continue. This is not possible. This is not possible. If this is not possible, what's there? Our assumption is wrong. Our assumption is wrong. What was your assumption? Root 2 plus root 3 is rational. So root 2 plus root 3 is not rational. Not rational. Not rational means one word substitution is what? Irrational. So finally root 2 plus root 3 is irrational. So again same, this is same, these 4 lines will be same. This is not possible. From where it came? This is irrational part, LHS, you see, clearly irrational, and this is clearly rational, because the operations of rational numbers means p by q is rational. So p by q whole square is rational. Rational minus 5 is definitely rational number. Rational minus rational, you will get a rational. So RHS is rational, right? And LHS is irrational. So irrational number cannot be equal to rational number. So this is not possible. If this is not possible, our assumption is wrong. What was your assumption? Root 2 plus root 3 is rational. So it is not rational. Not rational means irrational. Finished. So this is all same format for you. So this is very important, and this kind of question will definitely come in term 1 examination, 99% sure, and either 3 mark or 2 mark question is 100% it is coming in the term 1 examination, class 10 examinations. And students, if you practice this, and this kind of, this can be minus, this can be plus, no problem, but the format will be same. Take rational, take this bracket, this is important, you have to write this. If you don't write this, your mark will be cut. And this 4 steps is common, and squaring both the sides if needed. When you square both the sides, if both are roots, if one is root and one is rational, don't need to square. That is very easy, that is more easy, right? And about root 2, root 3 and root 5, that one I told in the beginning, that is same format actually, same format. Similarly, you are taking squaring both the sides, then you are writing, 3 is a factor of p, 3 is a factor of q, so that is common factor of p and q, but our assumption is wrong because you have taken HCF or common factor is 1. So if our assumption is wrong, then root 3 is not rational, that is irrational. Same format. If you practice this, definitely your 2 marks or 3 marks is 100% gettable or achievable. Keep shining and keep growing. Thank you.